Okay, so our group's major is Mechatronics. Mechatronics is an interdisciplinary branch of engineering. That means that it contains several other types of engineering. Specifically, Mechatronics engineering focuses on integrating mechanical, electrical, control, and computer systems. Mechatronics is described as an approach aiming at the synergistic integration of mechanics, electronics, control theory, and computer science within product design and manufacturing in order to improve and optimize its functionality. Without one of these components in a project is not a mechatronics project. The two main fields of mechatronics are robotics and automation. However, Dr. K, a professor teaching in our major, mentioned that since mechatronics is such a broad range of subjects, we can focus more on specific parts we like, for example, like the software part, and find a mechatronics career from that.
Just looking at my mock's degree, we can get a general idea of the classes we're going to take during our college experience. Some of these classes include 2 and 3D modeling, engineering design, material science, which is about understanding the major types of materials in the world, materials under those classifications, and what they are used for, or how we can use them in our projects. Digital electronics, digital electronics and microcontrollers, fundamentals of computer science, and intro to mechatronics engineering. There are many other classes that mechatronics students take, like mechanical and electrical engineering courses, like industrial safety, and other technical electives. All of this confirms how versatile a mechatronics degree is and shows how interdisciplinary it really is.
It can be concerning knowing that you have to learn a large array of subjects, so we had interviewed the president of the Mechatronics Club, Cameron Schofield, a senior level student. During the interview, we asked him for advice on this matter. His advice for us was that we should be willing to work with others and not be afraid to ask the professor for his assistance. He also said that making connections in classes is important. If in any case you needed help understanding the wide array of topics under the mechatronics. When we asked Dr. K, he gave advice more tailored to helping us in finding careers. He mentioned that starting early and working on developing your skills even as a freshman is a very helpful way of increasing your marketability to employers. For example, looking at online courses for skills like coding in Python or anatomy if you're going into biomechatronics.
We also asked them about what career development activities we could participate in during our college experience. One of their suggestions was joining clubs. Dr. K mentioned the Mechatronics Club. Of course, there we can undertake different mechatronics projects. And involvement in being in clubs looks great on resumes, and going into career fairs and club fairs are another great way to network. Cameron mentioned that he found his future job at one of the UTC career fairs because he mentioned he was in NSBE. So this confirms that being in clubs and attending career fairs are very important. Dr. K also suggested that we look into undergraduate research, which involves reaching out to a professor and joining them in the research that they're doing. Finally, he suggested that we find an internship during our junior or senior year.
During the interview, Dr. K mentioned that he's overlooking groups of students who have started their own mechatronics projects. These projects are connected to bigger industries and take 2 semesters to complete. Even though we are freshmen, he extended the offer to us so that we can join these students. Although they are halfway through their current projects, we can still get experience in the building stage of the project. In addition to this opportunity, our group learned about how diverse mechatronics jobs are. Dr. K is a biomechatronics engineer, and he also mentioned that NASA needs mechatronics engineers. And mechatronics engineers are needed for smarter, futuristic cars and other projects like that.
Mechatronics is special because it combines several disciplines. The skills from these disciplines are useful in careers and our daily lives. Dr. K loves to help disabled individuals by making tailored prosthetics for them. And our group personally is excited about going into careers like control engineers, robotics engineers, and automation engineers. We're also excited about using these skills in our daily lives. If our garage is malfunctioning, we can find the sensor or motor that's not working properly, or whatever component it is, and fix it, and maybe even improve it in the process. Mark Rober is a good example of how our engineering knowledge can be used in our own personal projects, which can be entertaining in our daily lives as well. Mechatronics engineers undertake fun and progressive projects, and we look forward to that.